Hello and welcome to helpyourmath.com. In this video, we're going to look at calculating compound interest when the interest is compounded more than once a year. Just like with the video when we saw it compounded once a year, you definitely want to have a calculator handy. Let's get started. So when we're finding compound interest, we can find the future value of an account with compound interest using this formula. So we have the future value is equal to the present value times 1 plus the interest rate divided by, and here's the new variable, the number of times the interest is compounded per year. And then we have raised to that n again, so you see that variable used twice, n times t, where t is the number of years between the future value and the present value. Be really careful when you're plugging this into your calculator. I always suggest writing everything out first, and before you plug into your calculator, figure out what this product is. You're going to want to know that product, because if you don't do that and you type it in your calculator and then you say to the whatever 4 times 7, if you do that, it's going to follow order of operations and it's going to raise the parentheses to the fourth, and then it's going to take that result and multiply it by 7. So just be really careful with plugging into the calculator. Okay, so let's talk about that new variable n. Compound interest is compounded a certain number of times per year. And then there's some more common periods. So annually is once a year. And you'll notice if you plugged 1 into that formula, you would end up with the compound interest formula when it's compounded once a year. You would have future value equals present value, not equals, times 1 plus r over n, where n would be 1, so that'd be 1 plus r to the n times t, where n is 1, so it would just be to the t. So we saw that formula in the last video. If it's semi-annually, then n equals 2. So what we're talking about here is we're talking about that variable n. Then n would be 2. If it says that it's compounded quarterly, n would be 4. Compounded monthly, n would be 12. Compounded weekly, n is 52. Compounded daily, n would be 365. Let's look at some examples. So here we want to find the future value for $1,500 at 4.2% interest compounded quarterly for 3 years, and we're going to round our answer to the nearest cent. So we're missing future value equals present value times 1 plus r over n to the n times t. And now let's figure out what all these variables are. Future value is what we're missing. The present value is 1,500. The interest rate, remember we need to convert this to a decimal or to a fraction by dividing by 100, so that would be 0.042. N, so we need to find where it tells us, it says it's compounded quarterly. Remember what quarterly refers to? It refers to n equaling 4, meaning it's compounded 4 times a year. And then we have n again is 4, and the number of time is 3. What I would do from here is I would then calculate n times t just to have that number. That would be 4 times 3, which is 12. So it's really annoying to do all this work and then to have the wrong answer because the calculator followed order of operations. All right, so plugging this in, we have future value equals 1,500 times 1 plus 0.042 divided by 4 to the 12th. If we do the calculation inside the parentheses, 0.042 divided by 4 is 0.105. And then if we add 1 to that, that would just be 1.0105. 0105. And then if we just type this in our calculators, making sure it follows order of operations, remember the only thing we want raising to the 12th power is this here. If you try to raise 1,500 to the 12th power, you're going to get a super ridiculous number. The calculator probably won't even calculate it. In the end, I end up with a future value of approximately $1,700.31 rounding to the nearest cent. So that's how I would use compound interest in this particular question. The next question, the first credit card Angie receives charges 12.49% interest compounded monthly to its customers. Yikes, that is a terrible interest rate. Within 1 day of receiving it, Angie maxes it out. Whoops. If she does not buy anything else on the card since then and owes the debt collector $1,938 after 8 months, how much does she receive on that first day? Round your answer to the nearest dollar. Now, one thing that's really important to know here is that this is written in months, and the t in the formula is time in years. So we have to be really careful about that. Let's set up what we know. So we have future value is equal to present value times 1 plus r over n to the nt, n times t. In this case, we know that the future value is $1,938. We don't know the present value. I think that's what we're trying to figure out. Yep. The interest rate is 0.1249. And It's compounded monthly, so n is 12. And then remember, time is always in years. This is time in years, and it says 8 months. So that would be 8/12ths of a year, which if we wanted to simplify that, you could. That would be 2/3. You don't have to simplify it. You're going to plug it into the calculator, so it's up to you if you want to simplify or not. But what I would do is I would calculate that n times t, so we don't make that mistake. And n times t here would be 12 times 2/3, which ends up being 8. When we plug in these values, we have 1,938 is equal to our unknown times 1 plus 0.1249 divided by 12, it's monthly, raised to the power of 8. When we get all this work, so it's important to know that I tend to be a perfectionist and I want everything to be exact. So even though there's a lot of rounding involved here, when I'm actually typing into my calculator, I keep using the exact values so that I can get the exact answer. Presumably your instructor will tell you a certain place to round to, and so there might be a slight difference between your answer and my answer if you round along the way. And when I give you the values here, know that these are the rounded values, but then as I said, in the calculator, I use those original values. Okay, so we have 1,938 is equal to the present value, and then when I calculate this, I end up with about 1.01041 to the 8th power. And when I'm going to come up here now, 1938. When I calculate this, I get some number similar to 1.0864 times the present value. To get present value by itself, I need to divide both sides. And I end up with a present value. It says round to the nearest dollar. So when I use these, plug in these values, I get 1,783.932499. So that's going to bump it up. That 0.9 will bump it up. So Angie spent about $1,784 on that first day. And now she already has $200 worth of interest. Yikes, no good. Okay, so on this last slide, there's 2 examples for you to try. Pause the video, try them, and then you can compare your results to mine. Okay, for the first one, a newborn is given a college bond. That would be the present value, is $10,000. The guaranteed rate of return on this, so that's our interest rate, is we're going to just plug it right in as a decimal. That's dividing this number by 100, right? Putting that over 100 is going to give me this. Compounded semi-annually, so n is 2. And she's going to have this when she enters college when she's 18, so t is 18. I would go ahead and calculate my n times t value, and that is 36. Okay, so now we want to know the future value. How much is she anticipated to have in 18 years? That's going to be 10,000 times 1 plus 0.0416 divided by 2 raised to the 36th power. Cleaning up what's inside the parentheses, there we go. We end up with, I get approximately 1.020, actually that's not approximate, that's exact, because dividing by 2 is not going to have anything repetitious there, to the 36th. And then when we calculate this, when I multiply everything and raise it to the power, well, when I raise this to the power of 36 and multiply it by 10,000, I end up with 20,982 point, and I get 8178. This says round to the nearest dollar, so we're going to say that her account will have $20,983, right? Because this 8 tells the 2 to bump up. Last example, find the present value. So we're missing present value, so we should have a future value. Future value is 24,000. And we have an interest rate of 0.065. And it says that it's compounded weekly, so n is going to be 52. And we're talking about 9 years, so t is 9. Multiplying this together, n times t, we end up with 468. Okay, so plugging this in, we get 24,000 is equal to our unknown times 1 plus the interest rate divided by 52, our n, to the 468. All right, working through this, we have 24,000 is equal to our present value. When I look at this, I end up getting 1.00125 to the 468. When I calculate this, 24,000 is equal to present value times
I end up with 1.7943. So I'm going to divide both sides by this amount, 1.7943, 1.7943. And I end up getting 13,375.42611. This is telling me to round to the nearest cent. So that present value would be $13,375.43 because I had a 6 behind the 2, which is going to bump it up to a 3. And again, if your values are slightly off, even by a couple of dollars, that might just mean that you use some rounded figure somewhere along the way, and that should be okay. And anything plus or minus like $2 or $3 here should be just fine. These have been examples of compound interest when the interest is compounded more than once a year. Thank you for stopping by.